Is that okay?
Yes, ma'am.
Because a lot of students lose their marks because they don't include diagram. Geology is all about diagrams. You can see the core. Hello?
Hello, ma. Please come again with the diagram stuff, ma.
Okay, I said when you're asked to describe anything in exams, always include the diagrams because you lose marks when you don't include diagrams. Do you understand?
Yes, ma'am.
Anything you can explain with a diagram, use the diagram. You get your marks for adding a diagram. It shows that you understand the concept. Sometimes, probably because of English, because of background, some students the way they put their words does not really make sense. But once you have a diagram, the lecturer will know, oh, this one have understanding. Are you following?
Yes, ma'am.
Yes, ma'am.
So just with diagram and your explanation, you get your full marks. You won't end up having half mark. So anytime they ask you to do something, always add diagrams. So here it is showing that you can see the asthenosphere. Look at it. Okay, we have the mantle. I said we have the inner core, the outer core. We have the mantle, lower mantle, upper mantle. Then you have the asthenosphere, which is the fluid part, semi-fluid, not really fluid. It's kind of thick, very thick, extremely molten kind of. It's just like you put a plastic in fire and it started melting gradually. No, it's still thick. And that's what we have here. So on top of it, that's where you have the lithosphere. Look at your lithosphere. The lithosphere is a combination of the crust and some part of the mantle, because the asthenosphere is part of the mantle. So it's just some part of it, just a small bit of it. What is separating the asthenosphere and the lithosphere is the monocevic discontinuity. I'm sure you have been taught that already. So there's a small separation here in composition between the two. So it's still the same diagram. Inner core, outer core, lower mantle, upper mantle. You have lithosphere here. You can see a small curve showing the size of the lithosphere. And above the lithosphere, you have your crust. And remember, your crust is divided into two types. We're going to be looking at the two types of crust that we have. Okay, I'm coming back there. So the continental crust, okay, let me start with the two types of crust that we have. We have the lithosphere, which I have already explained, right? The lithosphere is mainly the crust, both the oceanic crust and the continental crust, with some small upper mantle attached to it, which is joined to the crust. The separation is at the monocevic discontinuity, like I said earlier. So the lithosphere is underlain by the asthenosphere. That is to say, the lithosphere is sitting on top of the asthenosphere. Okay? The lithosphere is a rigid, strong outer layer that the crust is sitting on. Where we are now is part of the lithosphere. And this lithosphere is sitting directly on top of the asthenosphere, which is a fluid, molten fluid part of the upper mantle. Okay? It is weaker, hotter, and deeper part of the upper mantle, which is the asthenosphere. So the lithospheric plate is fragmented into what we call tectonic plates. And they move independently relative to one another. It is this movement that is described as plate tectonics. So the crust now, the crust is directly on top of the lithosphere. Look at our asthenosphere, the molten part. Look at our lithosphere on top of it. Then you have the crust very thinly on top of the lithosphere. Are we following?
Yes, ma'am.
All right. So the crust is divided into two. You have the oceanic crust, you have the continental crust. Do you understand?
Yes.
The oceanic crust is the denser, heavier crust. It is denser because the rocks that make up the oceanic crust are mainly gabbro and basalt. Do you understand? And
Yes.
gabbro and basalt are rocks that are rich in iron and magnesium, which we generally refer to as SIMA in geology. So that is to tell you now that this oceanic crust is heavier than the continental crust. Is that okay?
Yes, ma'am.
Sorry about I took a break. I was responding to Dr. Ozek. I'm so sorry about that. So the oceanic crust is heavier than the continental crust. Why? The continental crust is made up of mainly lighter element materials. You have aluminium, you have silicates, your silicate, which is a combination of silicon and oxygen. When you get there, you know how the silicate minerals formed. They are generally rich in a sodium, aluminium, potassium, and silicon and oxygen. And aluminum, silicon, oxygen. Those are what the silicate minerals are made up of. So they are lighter and they are generally called Cl. You can see their average density is between 2, generally less than 2.7. While the oceanic crust is denser, 2.9 to 3. Do you understand? So it means because of the difference in density, when you place the two of them, when they collide, one will definitely go beneath the other one. That is why you see in this diagram showing this one going down. The oceanic crust is heavier. It's just like the way we described density just now in we looked at what do you call it? Using differentiation or using rice and sand and all that. The heavier one will always go to the bottom and the lighter one will be at the top. So when two things collide, the heavier one will go down, the lighter one will go to the top. We're going to explain that extensively. So I'm just introducing the topic now, the cause. So when you are asked to describe the lithosphere, you should know that the lithosphere is the outer shell of the earth that is consisting of the entire crust, both oceanic crust, continental crust, and the the brittle upper part of the mantle. That is your lithosphere. Okay, you don't just say it's a rigid outer shell and you leave it there. You explain extensively what the lithosphere is and you add your diagrams. That is how you get your full marks in exams. Okay, I've already described that the oceanic lithosphere is made up of basalt and gabbro. That is rocks, highly dense rocks, right? Rich in iron and magnesium. While the continental crust, rich in feldspars, muscovite, and so on, because they are light, very light. They are not heavy minerals. So what is plate tectonics? I've already described it a little bit, but I wanted to introduce the concept before we come here. So plate tectonics is a theory that is used to explain why the rigid outer shell of the earth is broken into different plates that are moving on top of the asthenosphere. Okay, so it's the tectonic plates are massive, irregularly shaped slabs of solid rocks that make up this rigid outer part of the lithosphere. Okay, so they form like a jigsaw puzzle where you have different plates. When you put them lines against each other, you can see that they used to be together. Remember your I'm sure you would have done you know what Pangea is? Gondwana?
Yes, ma'am.
Okay, you know what that is before the breaking of the tectonic plates, right?
Yes.
All right.
Yes.
So it's plate tectonism that explained the concept that the Earth as a whole, most of those lithospheres were together as one. But something happened and they broke apart and they started drifting away from each other. We're going to be looking at all that during the course of this our course. Sorry, next week I hope to be around when we change it from early morning, please. I know some of you don't like online, but are you guys following me?
Yes, we
Yes,
are.
ma'am.
And you understand?
Yes, ma'am.
All right. That person that is making noise there, if I remove you now, you say I'm a bad person. You now come and use your own to disturb the whole class. So I said the plates, when put together, they fit together like a big giant jigsaw puzzle. You all know what jigsaw puzzles are, right? Do you know what a jigsaw puzzle is? You guys don't know what jigsaw puzzle is?
No, ma'am.
Okay. A jigsaw puzzle is I'm sure there are apps. I've seen games that are jigsaw puzzles. What they are is that let's assume you stand in a background, right? And you take a picture. Okay? You stand in the background, maybe there's flower, there's houses, there's tree, there's a car at your background, and we take a full picture of you. And I tear those pictures into small pieces. Okay? And I scatter them. And I ask you to come and arrange them to the original picture. Can it be done?
Yes.
It can be done, right?
Yes, ma'am.
That is what a jigsaw puzzle is. It's a puzzle you are supposed to solve. And it has to do with items separated, items that used to be one, separated from each other. And now you are trying to fit them together to see the whole picture. Do you understand?
Yes, ma'am.
I'm sure there are games. I've seen it on my phone popping up for me to download jigsaw puzzles. It will sometimes I've seen the one that is like a chicken or a painting of a lady or something like that. That is, the pictures will be scattered. Then you are supposed to be arranging them and putting the one that is close to the mouth, the one that is closer to the nose, you bring it above the mouth. Do you understand? You look for the eye, you bring it in. You look for the other eye, you bring it in. You look for the eyebrow. Do you understand? Are you following me?
Yes,
No,
ma'am.
ma'am.
Who does not understand jigsaw puzzle? Let me explain again. Anybody here does not understand what jigsaw puzzle is?
I don't understand now.
Ah, okay. Shebi, you've taken pictures, right? Don't you take pictures?
I don't understand, ma'am.
I said, don't you take pictures? Haven't you taken picture before? Chidera.
No, I'm not the one. No, I understand though.
Okay, who is talking? Who said they don't understand? Let me explain for you. Michael, is it you? Well, a jigsaw puzzle is when something that was together gets separated from each other, and you are asked to come and put them together, fit it back to the way it was. Okay? That's why I use an example of your picture. If you snap a picture, I've seen people do family puzzle pictures and the children try to fit it in. A family of 4 would take a family picture. They will take it, there's a place they take it to, and they break it down, they cut it into small pieces. And then you fit them. The pieces have edge like slabs, like they fit into each other. You normally give children to play with it, or adults, or anybody can play with it. And then you are trying to put everybody in the way the original picture is. Do you understand? You're trying to place daddy's head on top of daddy's body. You are trying to place daddy's hand because the picture have been broken down into tiny bits. And then you are asked to come and regroup it and arrange it into the way it's supposed to be originally. That is simply what jigsaw is. Okay? It can come in any form. It can come in pictures. So when they say it looks like a giant jigsaw puzzle, it's because they expected you to have known what jigsaw is. So the X is like different plates that used to be together, that was broken, separated. But if you put them together now, start trying to align them, bringing South America towards Africa, you will see that they fit into each other. You bring Asia towards the end of Africa, you see that it start coming together. If you start bringing North America towards South America, you see that it looks like those plates were close together. That is simply what jigsaw is. It's you rearranging things into the way it used to be. Is that okay?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So the tectonic plates are massive, irregularly shaped plates. Irregularly in that it looks like the picture that was cut. No, but you didn't follow a particular line to cut it. You just cut it, tore it. And then let's assume I tore my picture now, or somebody I didn't like. Maybe I had a picture, but all of a sudden, me and the person settled, and I feel like, okay, I still want to preserve the picture. What will I do? I'll bring sellotape. I'll start, if I tore it into 5 or 6, I'll start putting them together, right? And then I'll be using sellotape to hold it together. So that's what jigsaw is. So they are irregular plates that were not cut straight line, okay? They are just irregular slab of rocks, massive, that are floating on top of the asthenosphere. That is what the tectonic plate is. We already know the asthenosphere is a semi-fluid layer of the upper mantle. So when you place those plates on it, tectonic plates, they will be moving on top of it. Okay? That is how those tectonic plates move. You have the different tectonic plates we have. I think we have about 6 of them. We're going to be seeing all that later. So do you understand what plate tectonism is?
Yes, ma'am.
You understand?
Yes.
All right. So I can go on. So now, what do you understand by the plates moving? I've already explained that, but I'll still go into it. These plates are in constant motion. As we are right now, our plate is moving. The movement is slow, okay? That's why we don't notice it. Less than 2.5 centimeter per year to about 15 centimeter per year. That's to tell you how tiny these movements are. Very tiny, very tiny, very tiny. But they are moving from each other. Like the closest to us, the South America plate and the African plate that used to be together. And look at the vast distance between them now. You have the whole Atlantic Ocean separating the two of them. Why? Because they separated, they moved from each other. They separated. Is this plate movement? It's moving on top of the asthenosphere. If you look at the diagram here, you can see the lithosphere. You can see the arrow, right? Can you see the arrow?
Yes, ma'am.
Okay, you can see the plate moving. You can see another plate moving away. You see this ridge? We are going to be discussing what it's all about. Let's remember the mid oceanic ridge. I don't know. We're going to be seeing it. This ridge is where this separation is taking place. We're going to see why the ridge formed, how the ridge formed, and any other thing we need to know. So what happened is, you know that the mantle is very hot, right? Do you
Yes.
remember that the mantle is hot?
Yes, ma'am.
Fine. The mantle is very hot. Why? Because it is closest to the core. So the heat from the core is extremely hot. It's still working on the materials within the mantle. Do you understand?
Yes,
So,
ma'am.
okay, this plate movement, what causes the plate to move is called convection current. That is the major one. But there are three theories that have been put together to explain the plate movement. We are going to be seeing the three theories now. The first one is convection current. The second one is the ridge push. The third one is the slab pull. So what generally happens is it was the most accepted initially was the convection current, okay, which is believed to be the major reason. It is still a common theory. However, it is getting out of favor because of the new imaging techniques that is available for scientists to identify movement within the Earth's convection cells. Okay, so some plate movement shows this second one and the third one, the ridge pull and the push slab. We're going to be looking at each one of them. Some plates move faster than the other. Some plates move at a very slow pace. Some plates move at a very fast pace. We're going to be seeing all that, okay? So the pull slab pull helps to drive the mantle convection pattern. Okay? Okay, let me leave it now. Let me try to make you understand what convection is before we go into all that. So convection current is under high temperature, there is movement. Hope you know that. Hello? You know that atoms move under high temperature, right?
Yes.
When you heat your water, you put water in the pot and you are boiling it. What happens? The heat is coming from the bottom, right? You guys answer, let me know you're getting me. The heat is coming from the bottom. The water is cold. But after some time, you notice that the water starts moving. The one at the top, once it heats up, it gets lighter. It moves towards the surface. The one at the surface that is heavier, what happens? It moves to the bottom of the pot, right? Do you understand? That is how your water boils. Water boils by this process. Hot water moves to the top, cold water moves to the bottom. Hot water moves to the top, cold water. So it goes in a cyclic form. That is why water even boils in the first place. You see it boiling, because there is movement of what is at the bottom coming to the surface. What is at the bottom? In this time around, it is faster. Initially, it is slow because the water has not boiled. But the moment the water starts boiling, this process is very fast. That is why your water boils. So it is like a process, just the same makes what is the same thing that is happening in the mantle. You have at the close to the core here, you have very hot rock material. Do you understand? This hot rock material, because it got very hot, molten, it become lighter, less dense. It become more buoyant. Do you understand? It pushes itself towards the Earth's surface. Okay? And then when it gets to the Earth's surface, what happens? It starts cooling down. The one as it's cooling down is moving down, until it goes back again, get hot, come down, just like the same process I explained with the hot water. That is what is explained as the convection current that is moving this tectonic plate. You will have cold material got down, got heated, got lighter, more buoyant, pushed to the earth surface. The force of this is just like when you're boiling water, you put a small cover. Let's assume you put the cover of a Pepsi or Mirinda or Fanta, this plastic cover, you put it on top of it. You will see it dancing around, right, in a particular direction. Okay? Hello, have you put a plastic in the water boiling before? You see it moving round. It will go round, it will come back. It will go round, it will come back. Have you noticed that before?
Yes, ma. Yes.
Good. So it is the convection current that is moving it. It's taking it, the hotter one up. You see it will move to the side of the pot. It will come back again. The plastic will get towards the center. It will go back again towards the side of the pot. So the same thing, just the same process. It's like a conveyor belt for those that don't understand. You've gone to factories before. You see these conveyor belts that they put things on top and it pulls across. We have it at the airport. You have conveyor belts if you've been to the airport, whereby they put bags on top and it moves. You pick your bag on it. The same conveyor belt will move to the inside, pick another bag, bring it out. You pick up the same conveyor belt going round. Do you understand? It's similar process. So if this conveyor belt, just like this current, is getting heated at the bottom, it comes up, go again. So this movement causes a kind of force here where you have this, it is pushing this one in this direction, it is pushing this plate in this direction. Can you see the two plates? Hello?
Yes, ma.
You can see where there's a ridge, right? Beneath the ridge, you see where the end of the current is. You see this one. It's because this is how the water boils. It will push this one on this direction. This one will push this one on this direction. So it keeps going round. This one keeps going round like this. This one also keeps going round like this. Okay? This one clockwise. And you understand anti-clockwise. That's how the currents are moving around each other. This one will continue going cyclic like this. It gets cold, it comes to the bottom, it gets hot. It gets pushed to the surface, it gets to the top, gets cold, gets to the bottom, gets hot. That's how it goes around. The same thing with this one too. It gets cold, gets to the bottom, gets hot, come to the surface, gets cold, get to the bottom, push down, get to the bottom, get hot, get to the surface. Do you understand? You will notice that it creates a kind of force in this direction, a stress. We are going to see how this happens later when we're seeing rifting. So I'm going to go into explaining intensely later. You see that it will be pushing this one from here, it will be pushing this one from here. Do you understand? All right. So that is how these plates are pushed from each other. This one will be moving in this direction. The plates used to be together, just like your Gondwana, Pangaea, they were all together. Then when this thing starts, it will be pushing this one away from this second plate. This second plate also will be moving away from this, so that these two plates will start moving away from each other due to the force created by this convection current. Do you understand?
Yes, ma'am.
Yes,
So
ma.
I can go on. Can I go on?
Yes, ma'am.
All right. So you already understand the convection current now. So we still have another diagram similar to that first one I showed you. You have a plate. You have a plate now. This is moving in this direction. This is moving in this direction. Automatically, these two plates are being pulled apart from each other with force created by this movement. This intense heat occurring at the depths and creating gravity, forcing these two apart. Okay? This one will be moving away at very small centimeter. Let's assume 2 centimeter from measurements, some range up to 15. This one too will be moving away. Okay? they all start moving away. And there will be an opening after some time because it's just like separating tearing two papers, two things that were together. We put two boards together. Once you start separating them, automatically you're going to create a space in between them. Do you understand?
Yes, ma'am.
All right. So the convection are the cells results of heat generated by, it could be radioactive decay, elements in the mantle escaping into the surface. Remember, the mantle is extremely hot. It is the heat that is trying to escape into the surface. You know, as it's getting down, it's carrying heat. It will take more heat, bring it up, it will cool. Say, go down, take more heat. So it is bringing this heat to the surface. Go down, take more heat. That is exactly what is happening. Okay, I've basically explained the convection current already. So I don't know if I need to stay. I've already explained that the convection current brings the hot mantle material to the surface along spreading centers, right? This is your spreading center where you have this ridge. As these are pushed away from each other, more materials, molten materials will be coming up. We're going to be seeing how all that formed later. But I just want you to understand the concept. Do you understand the concept? All right. So you can see it is written here, convection current. You have the core, very hot, radiating heat, which is being picked up by this material. So this is an example of convection current. If you want to explain this plate tectonics, you must show this diagram to explain how these plates are being pulled away from each other. Do you understand?
Wait, sorry, we'll learn this diagram by heart.
You said?
Wait, we'll learn to draw this diagram offhand.
Yeah, you will have to learn to draw diagrams. You can draw simple one like this. You draw two plates. I can show you another simpler one. Just show that there's a current going this direction, a current going this direction. Your magma is coming towards the surface. This plate is moving away from this plate. This plate is moving away from this plate. That is all. They are very simple to draw if you want to draw it on the board. Let me see something. If I can see a simpler one. I think, okay, when I get there, I'm going to show you a simpler, or next time we are going to meet physically. I'm going to use my hand to draw it for you. Do you understand?
Yes, ma'am.
So that you see how you can easily draw it. It's not very big. So we've explained the first theory on why plates move, which is based on convection current, right? A lot of you said you understand that part. So the second one is the ridge push method. Okay. In this case, it is believed that magma is welling up. Look at it. As the magma is coming up, it cools, creating new elevated crust. You can see it's higher than the normal area, right? Because gravity pushes this elevated crust downward again, thereby sliding the rest of the plate forward. Look at it. It pushed it up and take it down. So this newly formed tectonic plates, okay, let me read what we wrote here. Newly formed plates at oceanic ridge are warm So they have a higher elevation at the oceanic ridge than the pole plate material further away. Gravity causes this higher plates at the ridge to push away, causing the plate to move away from each other. So this ridge push is that a ridge is formed here, okay? The ridge is pushed up, is higher, and because it has cooled down, it goes down, goes down, goes down up to the bottom. Convention, divergent boundary, and all that for you transform boundaries, different types of plate boundary. We're going to be looking at that later. I just want us to understand the concept of plate tectonics very well first. So what happened is that for the slab pool, one plate is often always pulled beneath the other due to density. Okay? Due to density, leading to the edge of the sunken plate, plunging deeper. You can see it going deeper into the mantle, so that gravity pulls the rest of the plates behind it like an anchor. Here you have this plate being forced together, but being forced under at the subduction boundary. The plate is being forced down here. That's the slab pull method. So the difference is that this one, you have hot buoyant magma rising at divergent boundary, where plate cools, and then this elevated parts, due to gravity, the plate starts moving away from this ridge. But in this one, occur at when when two plates collide and one is sliding under the other. Generally, it occurs at subduction boundary. I don't want to bring those terms here because I've not introduced them. Okay, so you have we're going to be looking at what subduction is later. You have the divergence, you have the subduction. This oceanic, the ridge push are generally associated with divergent boundaries. You can see divergent where there's separation, while the slab pull is generally associated with subduction zones, where one plate is being subducted under the second one. So due to this, there are 7 plates on the earth as we know it. 7 major plates. There are minor plates, but the 7 major plates we have are the North American plate, the Eurasia plate, the African plate, the South American plate, the Indo-Australian plate, the Pacific plate, and the Antarctic plate. Do you guys understand up till now?
Yes, ma'am.
All right. So, example, let me give example of this the South American plate and the African plate. Remember you said you've been taught all this already. So you have this one fitting into this one like a jigsaw puzzle. If you pull this one and you put it here, you see that it's like they were together before. But now you can see this vast Atlantic Ocean separating these 2 plates. And in between them, you have the ridge. The ridge is where the magma is coming up, where this event is taking place. Do you understand? Are you following? Yes. The ridge is where this event is taking place, where you have this current going in this direction, you have this current going in this direction. So that it is pulling these plates apart, it is pulling these plates apart. So that is exactly what we have here between South American plate and the African plate. You have the ridge, okay, in between, pushing this one because more magmas are coming in, the plates are separating. You can see the amount of magma that has formed, that has been emplaced to create this vast distance between these two tectonic plates. They were together. This process started gradually. We're going to see example of how the process starts. We're going to see example of those that are occurring presently and how they advanced up to this stage that you're seeing right now. So because this plate is moving away, South American plate is moving towards this direction. Who can tell me what will be happening to this plate? You said?
I didn't get the question.
You see, new crust is being created. Oceanic crust is being created. That's to tell you that the land is growing here, right? You can see all these are new land, new material, new crust. Do you understand? That was created over the past billions of years. Hello? If you put two exercise books together, are you following me?
Yes, ma'am.
You put two edges of exercise book, or you put two phones together, and you start separating them. What do you have in between them?
Space.
Space or distance. Do you understand?
Yes.
In this case, this distance or space is filled with magma. Do you understand? So it is creating new crust. Do you understand? These two were together before, but this one small space was created, very small. And others, the space keeps increasing as you are pushing them away from each other. And new magma is coming up from depth, from the mantle to fill the space. Do you understand what is happening here? Just to tell you that there is yeah. Yeah, it's creating land here. There's more cross coming here. You see, there's a distance now. There was no distance before. But the earth, okay, the theory is that this is occurring. And let me hear your question. Yes, the magma that is coming up is filling the space. The magma, as the space is created, the magma is filling it up. As space is created, any small 2 centimeter that opens up, magma will fill it up. Any small, I don't know if you understand. Okay, so magma is filling it up. You can see the distance between here and here is almost the same thing. While you have the ridge, that will tell you that the same amount of material that is being created here is the same amount. So magma is coming in through this. You see this fracture? Magma is coming in and is pushing these plates, from each other. It is now creating more land space where water, the Atlantic Ocean, has covered. We are going to see that process later. I just want you to understand this concept before we go there. Do you understand?
Oh, yes, ma'am.
I know your question now will be, if more land is created, is the earth growing? Is that what you want to ask? Yes,
Yes.
it's oceanic crust that is forming. It is forming new oceanic crust, not continental crust. These plates you are seeing are the continental crust. This blue you are seeing are the oceanic crust. Do you understand? Yeah. Yeah. So as this new crust is being added to the earth, and the earth is not growing, it means something is happening. The crust is being subducted somewhere. Do you understand?
No.
Okay, I will explain it to you. I'm going to explain it extensively. It's in I think about 8 slides from now, which we don't have time today to go into. You can see it here. The explanation is all here, so don't worry. I'm going to explain it extensively for you. But what I'm trying to say is, remember this plate, this diagram, right? You understand that the ridge is opening here and new material, mantle material, magma is coming in to fill this ridge. Do you understand that part?
Yes, ma'am.
Good. And you understand that as it is going, it gets to a plate, it becomes subducted, right?
No.
It goes, hello?
Hi.
All right, don't worry. When we get there, you'll understand. You've seen the slide I showed you that I explained it extensively. So let's do this one, then I'll come back and explain that one for you. Is that okay?
No problem, ma'am.
You guys should let me know when your time is up.
It's already past 10.
Do you have another class?
No, ma'am.
Should we continue? Or you're
No,
tired?
give this as class, man. Give this half class, man.
You said?
Give this is half class, man.
This is what?
Like
He
the
said
geophysics
your
is half
physics
class.
has in class.
Okay, you have a class.
Yeah.
Yes, ma'am.
Oh, all right. So we're starting next from different plates, okay? But don't worry, I'm going to explain what is happening here and why. Because as this one is growing, it means this one is reduced. I'm going to explain all that for you next. Is that okay?
Yes.
All right. Thank you for coming.